In this video, we're going to prove that triangles are congruent using the triangle congruence theorems in paragraph, flowchart, or two-column proofs. So I have a couple of examples. This first example, we're using a flowchart proof to justify these triangles are congruent. So we're trying to prove that triangle LMP, so this triangle on the left-hand side, is congruent to triangle NMP. In order to do that, we first need to look at what we're given. We're given that triangle LMN is an isosceles triangle with vertex point M. That vertex point M tells me which sides are going to be congruent. That tells me that LM and MN are the two legs of that isosceles triangle, and those are the sides that are congruent. MP, segment MP, is an altitude of triangle LMN, means that's the height of the triangle and that it's perpendicular to the base, forming a right angle right there. So we're actually going to use those implications in our proof. So first we start out with our given information. Now, triangle LMN being isosceles means we know which sides are going to be congruent. So I know side LM is going to be congruent to side MN by the definition of an isosceles triangle. MP being the altitude means we know that MP is perpendicular to PN. So we know we have a right angle. Now, we also know that MP is a shared side for those triangles. So I can also state that MP is congruent to MP by the reflexive property. Now that I know I have a side congruent here, that side that is shared, and we know that we have a right triangle, we can bring all of those back together to say that triangle LMP is congruent to triangle NMP by the hypotenuse leg congruence theorem. Since we know we have the hypotenuses, LM and MN, that are congruent, and MP, which is a leg for both of those right triangles. Next, we're going to write a two-column proof to justify that triangle ABC is congruent to triangle DCB. So what we're given is that AB is perpendicular to BC. So AB is perpendicular to BC means we have a right angle. CD perpendicular to BC means we have a right angle at vertex C. And then we also know that A and D are congruent angles. So first we always start out with our given. So those are the three statements that were given to us. AB is perpendicular to BC, CD is perpendicular to BC, and angle A is congruent to angle D. We also notice that side BC is shared. That means that BC is congruent to itself with the reflexive property. So we now have a set of sides. We know we have two angles in both triangles that are congruent to each other. So I know the triangles are congruent because of the angle-angle-side congruence theorem. Now it's worth noting here that because we knew we had right angles in those triangles, that we also could have used leg-angle congruence as the reason instead of angle-angle-side, and it still would have been a valid proof. And we'll practice more proofs when we come back to class.